Hello and welcome to Maths with Jacob. This lesson will focus on circle geometry problems. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. In earlier videos we saw many parts of a circle and looked at their basic properties. In this video, we will see how to solve a number of problems using these parts. Find the pronumeral for each diagram. Example 1. So we have here this diagram. Now when we look at that diagram, this is the rule pertaining to that diagram, and it says that the angle at the center of a circle is twice the angle at the circumference standing on the same arc. So here is the angle at the center of the circle, there is the angle at the circumference. So by the rule, this angle here is 94 degrees. 2 times 47 is 94. Example 2. If we see this diagram here, now that's the diameter, there is the center of the circle, and here is a triangle in that semicircle there. Now the rule says the angle in a semicircle is a right angle. So they're referring to that angle there. So when you have this construction, this angle here is a right angle. So if that's 70, therefore x is 20 degrees. Example 3. Angles in the same segment standing on the same arc are equal. Here's angle there. There's another angle there. Can you see they are in the same segment? Because if you take that line there, there's one segment here and one segment up the top. So those two angles are in the same segment. They're both standing on the same arc. They're standing on the arc AB. Hence they're equal. So A must be 80 degrees. Example 4. This is what we call a cyclic quadrilateral, because the points, the 4 points, each of them is on the circumference. And the rule is the opposite angles of a cyclic quadrilateral are supplementary. That means they add up to 180 degrees. So if that's 106 there, that means B must be 74, because 106 plus 74 is 180. If that's 87, that must be 93, so A is 93, because 87 plus 93 is 180, and that is a cyclic quadrilateral. Example 5. Now here we have an interesting little diagram. Here is a circle. AD is a tangent. OC is a radius from the center to the point where the tangent touches the circle, and OB is another line which completes the triangle. So AD is a tangent which touches the circle at C, that's there. The interval OC is the radius of the circle, so OC is the radius. Find OB, so we need to find that line there. If OC equals 3, so there's 3, and BC equals 4. Now here's the rule pertaining to this diagram. A tangent to a circle, there's the tangent to the circle, is perpendicular to the radius at the point of contact. In other words, that angle there is 90 degrees. So angle BCO is 90 degrees. We can use Pythagoras Theorem for the triangle BCO. In other words, the hypotenuse squared, which is OB squared, equals 3 squared plus 4 squared. So OB squared is 25, so OB is 5. So the length of OB is 5. Example 6. Here is a circle, and here is an external point P, and here we have two tangents. So PR and PQ are tangents, and they touch the circle at one point. So PQ and PR are tangents to the circle. If PQ equals 10, find the length of PR. So that's 10. What's the length of PR? Well, the answer PR is 10, and the reason is the two tangents drawn to a circle from the same external point are equal in length, and that's why PR is 10. Example 7. Find the size of theta. Well, theta is 60 degrees, and here's the reason. The angle between a chord and a tangent, okay, so there's the chord there, and there's the tangent. So in other words, that angle there, that one, so the angle between a chord and a tangent through the point of contact is equal to the angle in the alternate segment. And here is the angle here in the alternate segment. So theta is 60 degrees. Example 8, find the value of y. Here is a rule when you have this diagram. The tangent PT, so there's the tangent PT, and the secant PS are both drawn from the point P. So there's the point P there. There's the tangent PT. There's the secant PS. When you have that diagram, here is a rule. The length PM times PS equals PT squared. That is a rule that we're allowed to employ. So PM is Y. PS is Y plus 30. And PT is 20. So Y times Y plus 30 equals 400, which is 20 squared. So Y squared plus 30Y is 400. Y squared plus 30Y minus 400 equals 0. Factorise, which gives you Y equals 10. Example 9. The two circles are touching at the point E. A is the centre of the small circle, there. B is the centre of the large circle, there. DC passes through the point of contact, there. Find the size of angle BED. So we need that angle there, this one. Angle BED is 90 degrees. When two circles touch each other, the line joining the centres of each circle passes through the point of contact. CD is perpendicular to AB. And that's why that's 90 degrees. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle. What is the meaning of the following? Put the past behind you. And here are the answers to the quick quiz, and the video is at your disposal.